Hey there, so today we're going to check out how to expose some C++ to Blueprint in Unreal Engine 5. Let's go. So we're inside Unreal Engine, and as an example to show how to expose some C++ to Blueprint, we are going to build a simple camera system where we are going to rotate and place the camera around the player. So for example, here the camera is placed on the right, but if we go on the character class, there is a variable there, and this variable will control a value inside this map over there, and each entry of the map contains a location, a rotation, and a spring arm length, deciding the distance between the camera and the player. So for example, there I've choose left, so when we start, now the camera is placed on the left. So that's a simple way to show how to expose some variable like so, as well as to enable or disable a variable depending on another like so, and also expose some C++ function like those one, and also define an event, a Blueprint implementable event, where there is no implementation in C++, but we can call some Blueprint. And this event will be called each time we set the camera type. So for example, at the start we set the camera type following the variable that we've set on the class, but we can put a delay and set a new value after 4 seconds. So now let's just select value of right. Now, when we start, we're going to have the camera on the right, and after 4 seconds, camera switch on the left, and on the top left, the side displayed. And the print comes from this event, which is called in C++. We're going to check that. So now let's go inside Rider to see how we can build that. So we're inside Rider. This is the character class that the Blueprint class that we have seen implements. So there is all the camera logic stuff that we've seen with all the C++ exposed to Blueprint. But I've created a new character class which is similar to the character class provided by default by the third-person template. And we're going to use this class to re-implement all the camera stuff step by step to see how it's done and to see how to expose the C++ stuff to Blueprint. So let's start. So first thing we want to do is to create the variable that are exposed over there, those three there, to expose the camera type that we want to choose, the different camera type available, and also the boolean to either enable or disable the camera system. So what we can do is to create a new public and protected block, and in the protected block we can define the boolean variable, which is uProperty. So first we are going to define it as edit defaults only. We could use edit anywhere instead. What it allows us, the edit anywhere, is to expose this variable on the Blueprint archetype, as the text says here, but also to edit it on each specific instance inside the editor. I mean, once the instance is placed into the level. So for example, if we click on this mesh and on detail, all those variables there are edit anywhere because we can edit them for each specific instance. And edit defaults only means that those variables will be exposed here, like those one, on the Blueprint details, but not on each instance details inside the level. But here edit defaults only is enough because we want only to edit it inside the Blueprint. Second variable is the Blueprint read only. So this one is to expose the variable to Blueprint so that we can access it inside our Blueprint. For example, in our final Blueprint, here the camera type is Blueprint read only, because we can access it inside the blueprint. We could also use the blueprint read-write. So this one, in addition to be able to read it inside the blueprint, we will also be able to override it. But in this case, it's not really needed. So we can keep the blueprint read-only. And finally, we can set a category. Let's say camera. And this category is used there on the detail panel. It's this one over there. It will decide where the blueprints are sorted. So for example, here this is the actor tick category, here the camera option category, and so on. So it allows us to be more organized and to sort that a little bit. And finally, this one is going to be the B. Use dynamic camera, and we are going to set to true by default. So now we want to expose the second variable, which is the camera type. For that, we are going to need a new type, which is in C++ an enum. So we are going to define it here at the top of the class. And for that, we are going to use the Unreal Engine macro uenum with the blueprint type property, so that this enum is exposed to blueprint. And it's a standard C++ enum apart from the macro. So it's an enum class. And we're going to call it eCameraType tutorial, because the eCameraType is already defined in the demo class. And there is going to be, oh, I made a mistake there, camera. So default, so this is going to be the display name, which is shown in blueprint. And we're going to put the same, but in lowercase. And second one is stop. I mean, we can take this. I mean, we can take this, it will be faster. Top, then right. It's not mandatory to define them all, but let's just do it so that it's a little bit more clear. And oh yeah, there was the bottom one, because usually it's top right, bottom left. So let's keep that in that order. There we go. So we've got our enum. Now we can go back there, and we can take the same new property as the boolean. And this is going to be of camera type tutorial, and we can call it camera type is fine, and by default it's going to be well default. And finally, the last variable that we're going to expose is the different camera data for each camera type. So for that, again, we need to define a new type. This time it's going to be a structure. Same as the enum, there is a specific macro for this, and it's uStruct. And same as the enum, we need to define it as a blueprint type. And beside that, it's a standard C++ struct. So we're going to call it camera data tutorial. Again, the tutorial because the camera data is already defined in the base class there. So like an Unreal Engine class, we need to add the generate body so that our struct is recognized by the engine. And then we can define our constructors. So this is going to be the copy constructor. And we are going to first, I forgot something. First we're going to define the different properties of the structure. So properties, same as the properties that we have defined for the class. This one, it's not mandatory, but I like to make all the properties of a structure as defined anywhere, because the structure can often be set in the editor when the instance is put inside the level. So it's more convenient, I would say, but it's not mandatory depending on your use cases. And it's going to be a blueprint read-write. Again, it's more convenient, but if you're not using edit blueprint, it's not really mandatory. And this one is going to be the location offset for the camera. You can take that and do that same, but this time for the rotation offset. It's going to be rotator. And last property will be the distance from the camera, and this is the spring arm length, because it's the spring arm length that controls the distance from the camera. And now we can finally finish our copy constructor. So for the location offset, we're going to take the camera data, location offset, and same for the other two. Arm length, there we go, and the curly braces. And this is fine for our structure. Now we can go into our property, take the U property header like that, and define our structure. So this is going to be a T-map, because as key we are going to have the camera type tutorial, and for the value this is going to be our newly defined struct, so the camera data tutorial, and we can call it camera data. Camera data is fine. So now we are done with our properties. We can now define the functions. First thing we can do is to define the getter and setter. So those ones are not really mandatory, but it's just to show the different way to expose some function to Blueprint. So first there is the macro U function, which is a bit similar to the U property, but it is for functions. And the first property is going to be the Blueprint callable. This one is needed if you want to call this function from Blueprint, as the name says. Second property is the Blueprint pure. So this one is used so that we can call our function directly without the exec node, a little bit like this one here. So for example, we can call the get camera type there, and this is going to be a node like so without the need of the exec node. So that's what the Blueprint pure property does. So now we can add the last one, which is the category, and it's going to be the same as the property camera. I can't spell it. We're going to return a camera type tutorial, get camera type, and for those one I like of course to add the const, because it does not have any side effect on the object's property, and because the function is very short, we can add the implementation there. There we go. Is it needed? No, it's not needed. So this is the get camera type. Now we can add the set camera type. This one is not going to be Blueprint Pure. There we go. It's going to take the camera type tutorial as a parameter. Camera type. And this one we can add the declaration in the CPP file. Let's add same as this port for the camera type. Let's call it dynamic camera, and we can take that. So this function is going to be part of the class, so we need to add like so. And let's just call the argument something like new camera type rather. It will be a bit more clear. There we go. So what we want to do is first to check if the camera data contains data for this new camera type. Because if it does not, it's useless to continue. So we've got our camera type, so we are going to set it to the new camera type. Then we are going to get the camera data from the map, which is the camera data. Let's call it new camera data rather. And now we're going to, because we know that the camera data contains data for this new camera type, so we can use the find check. But when we are using this find check, we need to be sure that it contains the elements, otherwise it will throw an error. I think you can check out. It will trigger an assertion if the key is not here. But there we are sure. So we just need to give that. And now we can modify our camera and spring arm following this new camera data. So this is the follow camera. And we're going to add a relative location of the location offset from the new camera data. And we're going to do the same for the rotation. There we go. And for the spring arm length, we need to take the camera boom and get the target arm length and set it to the spring arm length. Yeah, spring arm length from the data. And we need to do something about the location and rotation, because the first time that we're going to set the camera type, it's fine because the relative location and rotation will be default to 0. But if we call this a second time, the location and rotation will be different than 0. So we need to reset them before adding a new offset. So we need to take the follow camera and set the relative location to a vector of 0. Does the null exist? 0. I think this is fine. Let's check the implementation. 0 vector, yeah. Yeah, that's what we want to do. and same for the rotation. F rotator, and maybe the zero rotator, yeah. This one is fine also. Maybe that? No? I think so. And what we can do also is to go back to the .h file and define something called a blueprint implementable event. So we are going to make it blueprint callable and add the blueprint implementable event property, and same with the category with the camera. And this is going to be a function, so let's call it on camera type update, and we are going to call it each time the camera type is changed. New camera type. So what is a blueprint implementable event? Well, it's a function that we're going to only implement in Blueprint, so there is no implementation in C++. And in Blueprint, on the demo Blueprint class, it looks like that. So it's a simple custom event that we need to implement by right-click and just typing the name of the function. So it's on camera type. There you go. So this is already implemented, and it's as simple as calling whatever we want. There I just did a print, so to print the new camera type. But yeah, it's as simple as that. Only the implementation is only in Blueprint, not in C++. And by the way, if your Blueprint implementable event has a return type, it's not going to be a custom event like that. It's going to be a function. So it's going to be on the override panel like so. So now all our system is implemented. We can go back to the editor, build, and recompile the code using live coding. That is done. So we can take this blueprint third person and change the parent class to the newly C++ class that we've just created. So this is the one. Yeah, we are going to reparent. And now we can do the same as for the old blueprint class. So first, let's check the default detail. We should have all the new variable exposed. Here they are. So the boolean, the camera type, and the camera data. And I forgot something actually, because in the blueprint we would like to disable those two fields if the use dynamic camera is disabled. So for that we need to go back to C++ and add to the true properties something called meta, which are going to be different metadata for the field. And the one that we want to use is the edit condition. So as the name says here, it indicates whether we can edit or not this property depending on a boolean value. And the boolean value that we're going to use is this one, the BUse dynamic camera. So what it does is we can only edit this property when this condition is true, and we can do more advanced things like adding negation, for example, but it's not really needed for this one. And we're going to add it also for the second property. And if we go back to the editor, let's compile again. So this is done. Now we can go back to the blueprint and check whether it's working. When we disable the dynamic camera, the two properties are disabled also. So we don't want to do that, but it's just to show that we can do that. And we just need to add an offset on the y-axis, so this one, and we're going to add -90. For the right one, we're going to do the reverse, so 90. Then top one, this time we're going to add an offset to the z-axis, and let's say something like 40, and the bottom one. So I'm doing the default at last, because if the default value is already present in the map, we can't add other elements. For example, if I pick default here, if I try to add something, I can't, because the default is already is not available. So for the bottom one, we're going to take the same offset as the top one, but reversed. And finally, the default one, we're going to change nothing. We could add more data, for example, a close one, but we will need to add a new type, and close one will be with the spring arm length smaller, but this will be fine for the demonstration. So at begin play, by default it is default. What we can do also is implement the blueprint implementable event that we've defined here, this one, the on-camera type update. We just need to type the event name. There we go, and we can implement it. So we're going to do the same as the demo at the start of the video, and just print the new type. And we're going to keep the defaults for now. And what we just have to do is to change the default point class. This one was the final one for the demo at first, but we're going to use this one. That's the one that we have just modified right now. So now if we start the game, it should work, and the camera should be default location, default rotation. Now if we go back to the character class and change it to, let's say, left. Oh yeah, I forgot to do something, because there we are changing the camera type, but we are using the value there, so we just need to plug our camera type variable, this one here, so that it's taken into account at start. So we have chosen left, and as you can see, the camera is placed on the left of the character. And of course, if we choose another value, it will change. Oh damn it, I've lost it again. There we go. Let's say top. And there. So this one is less obvious compared to the left one, but you can probably see that the camera is placed a bit higher than usual. And that's pretty much it. That's how we expose some C++ to Blueprint class. And of course there is more stuff. I didn't show everything, but Epic Games provide good documentation to list all the fields on the U property. I will link those in the description if you want to check them out. But beside that, we are done. Hey, so that's it for this one. Thank you for watching. If you enjoyed the content, you can thumbs up, subscribe and share like always. And see you another time. Bye.